Welcome back to the Stat 201 Beyond the Lecture video series. This is going to be lesson 2.7, which is about z-scores and outliers. That's going to be our big goal for this video, which is to be able to calculate and interpret a z-score, as well as to use that z-score to decide is a data point an outlier or not. The question, why this matters? Well, if we're trying to compare values, specifically if I have points in different data sets that aren't really particularly similar, I can use z-scores to compare those data points, even if, again, the data that they come from is very different. The other question that we tend to ask in research is this data unusual? And that's where the word outlier comes in. If the data is unusual for the rest of the data that it's around, we'll call it an outlier. So I'm going to jump into z-scores. And the first thing I'm going to do is present this formula, which z just represents the z-score. And we're going to find it by calculating x, which is our data, minus mu, which is our mean, divided by sigma, which is our standard deviation. There is one thing that I would generally recommend to people to add to their formula, which is parentheses, so that they remember to do the subtraction part first. So do data minus mean, and then divide by the standard deviation. As part of this, the z-score is going to have two parts. The direction is going to come from the sign of the z-score. So if the sign of the z-score is positive, that tells us it's above average. And if the sign of the z-score is negative, then that's going to tell us it's below average. The other thing we're going to get from a z-score is the distance, which is a value. So I'm going to drop the sign, whether it's positive or negative, and just look at that number. That number is going to tell me how far from average that my data actually is. We're going to use that information to try to describe outliers. So our expectation is that most data is going to be near the mean. And that's what I've tried to describe in this picture, is that most of the data is close to average. We're going to have less and less data the further we move away from the average. And at some point, we have to have a cutoff and say, at this point, it's really unusual. It's so weird for me to get something very far from the average. And so we're going to use the cutoff of -3 and 3. And so if our z-scores are between -3 and 3, these will not be outliers. But if our z-score is outside of -3 to 3, so if it's below -3 or above 3, that's when we start calling it an outlier. I'm going to use this time to jump into an example. And so at the McCutcheon House, we have a restaurant operated by students in the School of Hospitality and Tourism Management at the University of South Carolina. One concern is for how long it takes for guests' entrees to be served. Over the course of 1 week, the average wait time, so that is our quantitative variable, was 18 minutes. And that's our mean, with a standard deviation of 4 minutes. At this time, pause the video and try this problem on your own. So one table was observed to wait 32 minutes for their entree. So this will be our x value. That's going to be our data. Our mean, again, was the mu symbol. And this is our standard deviation, the 4 minutes. So that's going to be our sigma. So I'm going to fill in the formula because it's asking me what is the z-score for this wait time. So z equals x minus mu over sigma. So again, the data is 32 minus 18 divided by 4. And so again, make sure you do the subtraction first. So 32 minus 18 gives me 14. Then we'll divide that by 4 and we'll get 3.5. And so that is our z-score, 3.5. Again, pause the video and try the rest of this question on your own. So one table was observed to wait 32 minutes for their entree, so that is our data. So the question here says write the interpretation for this wait time. So the first thing I'm going to do is write some context. So a table that waited 32 minutes for their entree, and again, that's our context, is 3.5 standard deviations above the mean. So there's a few things that I always look for in this particular interpretation. So the first part is that you give me some kind of context related to the problem. I'm also looking for the number that goes here. You do not need to include a sign, so ignore whether it's positive or negative. You should also say the word standard deviations. You would tell me whether it's above or below the mean. Again, that's related to the sign. Since the z-score was positive, we know that it's above the mean. And then that's the other thing I'm looking for at the end, is that it'll at least say mean or average. So that's how we will always interpret these. So give me some context, tell me the number, and that's in terms of standard deviations. Then you'll tell me about the sign, whether it's above or below, and then add in the word average or mean at the end. Finally, here we have another problem. So pause the video, try it on your own. So again, one table was observed to wait 32 minutes for their entree. Is this wait time unusual enough to be considered an outlier based on the z-score rule? Well, again, our z-score was 3.5. Anything bigger than 3 as far as that number means yes, it is an outlier based on the z-score rule. All right, I'm going to do one more example. And in this example, we have the Wellness and Fitness Center at the University of South Carolina uses a variety of cardio machines. Each type of machine has different average distances and variability. It can be difficult to compare performance directly. During 1 week, the following data were recorded for distances covered during 30 minutes. And so we've got treadmills and ellipticals. We have means and standard deviations for both of them. One student ran 3.4 miles on the treadmill on one day and 4.6 miles on the elliptical on a different day. What we want to do here is calculate the z-score for each workout. So we'll do treadmill first. And again, we're going to look at the data, which in this case is the 3.4 for the treadmill, minus the mean, which is 2.5, and divide by the standard deviation, which is 0.5. So I'm going to go ahead and work on this in the calculator. We're going to do 3.4 minus 2.5, and that gives me 0.9. Then we're going to divide that by the 0.5, and we will get 1.8 as our z-score. Then we'll do the elliptical, and we're going to do the same thing. So we're going to look at the data, which is 4.6 miles, minus the average, which in this case is 3.8, divided by the standard deviation, which for the elliptical is 0.7. 4.6 minus 3.8 gives me 0.8, and we're going to divide that by 0.7. which gives me about 1.14. I'm going to round to 2 decimal places. It keeps going after that, but 1.14 is what we'll do. So there's the z-score for the treadmill and the z-score for the elliptical. And again, pause the video and try this part of the question on your own. This question asks, which workout was more impressive relative to typical performance on that machine? So the question is, which one is more unusual? And so which one had a bigger z-score? And in this case, the answer is the treadmill, because the z-score was 1.8 versus 1.14. So the treadmill had a larger z-score. I'm going to go ahead and recap at this point. Z-scores are a measure of position. They describe the distance from the mean in terms of the standard deviation. Outliers are unusual points, typically far from the mean. These would be things that are more than 3 standard deviations from the mean. And finally, the big pitfall to watch out for is the order of operations in that formula. Make sure you subtract first, which is why I suggested using parentheses, and then you should divide afterwards. I hope that this helps, and I will see you all in the next video.